Now the next section we're going to move on is a little bit more difficult. It can take a little while to get your head around this. So if you don't get your head around it with these 3 examples, don't worry. It takes a lot of practice to realise what's going on. So we're going to factorize quadratics now. And the first question asks us to factorize the following expressions again, and we have x squared plus 3x plus 2. Now whenever there's a variable squared and the squared is the highest order of the expression, then always associate that with quadratics. And whenever I think of quadratics, especially factorizing them, I know that it's likely that there's going to be a double bracket involved, so I know there's going to be 2 brackets. So we're going to have x squared plus 3x plus 2 is equal to, and then what we'll do, we'll set our brackets up here because we know it's going to be in that form. And I know it's going to be in that form because it's in the form of ax squared plus bx plus c. Now to be able to factorize this, what I like to do is set up a little table like this. And in the first column, I place what the b value is. So b is this middle term here. So we have b is equal to 3. And then at the top of the second column, we have a times c. So we have a as 1 and c as 2. So we know that we're going to have a times c as 2. And then what we want to find is we want to find 2 values that add together to make the value of b. And then the same 2 values need to times together to make the value of a times c. So with this example, it's quite easy. We can notice that 1 plus 2 would equal 3, which is what our b value is. And that 1 times 2 is equal to 2, which is what our a times c value is. So this would mean that 1 and 2 are the 2 values we need. And then what we do with these is we place them inside the bracket to say that x plus 1 times x plus 2 is the factorized version of x squared plus 3x plus 2. And we can check this just by expanding this again. So we have x plus 1 times x plus 2. So let's just expand this. So we have x times x, which is x squared. Then x times 2, which is positive 2x. And then 1 times x, which is just positive x. And then 1 times 2 is positive 2. So we'll piece this together, we have x squared plus x plus 2x plus 2, which gives us x squared plus 3x plus 2, which is the same as the original expression. So on our final answer line, we want to write x plus 3 times x minus 2. Now don't worry if you didn't get that, it does take a little while to get your head around. I'm going to do 2 more examples just so you can get familiar with the method. So the next example we have is x squared plus 5x plus 6. And we'll set up our little table here. We have b is equal to 5, and we have a times c is equal to 6. And we want to find x squared plus 5x plus 6. So we'll start off doing 1 plus 4, so that's equal to 5. And then if we have 1 times 4, that would be equal to 4. So we do have a b value of 5, but we don't end up with our a times c value of 6. So we'll try again. So next if we do 2 plus 3, which equals 5, and then 2 times 3 equals 6, which is the value we need. So we know that the 2 values we want are 2 and 3. So this means if we set up our double brackets, we have x plus 2 times x plus 3, and then let's double check this by expanding. So we have x plus 2 times x plus 3. So we have x times x, which is x squared, then x times 3, which is 3x, 2 times x, which is 2x, and 2 times 3, which is 6. So we have x squared plus 3x plus 2x plus 6. And then that's equal to x squared plus 5x plus 6, which is our original expression, so we know that our solution is correct. So on our final answer line, we want to write x plus 2 times x plus 3. Now the next example we have is x squared plus 10x plus 24. So we'll set up our table here. We have b is equal to 10 and a times c is equal to 24. So we want to work out x squared plus 10x plus 24. And we'll start with 1 plus 9. So 1 plus 9 is equal to 10. And 1 times 9 is equal to 9. So 1 and 9 aren't any good. So let's try 2 plus 8, which is equal to 10. And 2 times 8 is equal to 16. So they're not any good either. So we'll try 3 plus 7, which is equal to 10, and 3 times 7 is equal to 21. So we are getting closer, so let's try 4 plus 6, which is equal to 10, and 4 times 6 is equal to 24, which is the one we want. So we know that the two values we need are 4 and 6. So this means that x squared plus 10x plus 24 is equal to x plus 4 times x plus 6, and then let's double check this. So if we have x plus 4 times x plus 6, then we have x times x, which is x squared, x times 6, which is 6x, 4 times x, which is 4x, and 4 times 6, which is 24, and then this simplifies to x squared plus 10x plus 24, which is the expression we started with, so we know our factorized version is correct. So on our final answer line, we want to put x plus 4 times x plus 6. So there's a couple of questions there for you to have a go yourself. If you do struggle and you can't quite crack it, don't worry too much. I will talk about that later on in this video. But for now, we're going to move on to exam style questions. So the first question asks us to factorize x squared minus 3x. So we should be able to do this quite easily, as it's very similar to the ones we've done. So we have x squared minus 3x is equal to, so if we find the highest common factor of x squared and minus 3x, we can notice that there's an x in both terms, so we know an x is involved. And the first term is x squared and the second term is minus 3. So that means we have 1 and minus 3, which means the highest common factor there is 1. So we have 1x. So if we divide that by both the terms, we have x squared divided by x, which is equal to x. And we have minus 3x divided by x, which is equal to minus 3. So that means we have our factor, which is x times by x minus 3. And then let's just check that's right. So we have x times x minus 3, and x times x is x squared. And x times minus 3 is minus 3x, which is the original expression. So on our answer line, we want to write x times x minus 3. Now, the next question asks us to factorize xy plus 3y. So this time there was two variables on the first term. So we have xy plus 3y is equal to the highest common factor of xy and 3y is equal to, well, there's a y on both terms, so we know a y is included. And then the highest common factor of x and 3 is 1, because we have 1x and 3. So we know that we're just left with y as our factor. So we have xy divided by y is equal to x, and 3y divided by y is equal to 3. So that means we're left with y times x plus 3. And then we can double check this to give us y times x plus 3 is equal to, well, y times x is yx or xy, and y times 3 is 3y. So we're left with xy plus 3y. And that's the original expression, so on our answer line we can write y times x plus 3 as our answer. Now the next few questions I'm going to leave for yourself to do, they're nothing too tricky, but question 4 and 5 is slightly different. We haven't exactly gone through this. It gives you the factorized version of the expression and it makes that equal to 0. And it's wanting you to state the values of when that equation is true. So what values of x would make the equation true? So just have a little think about that. Don't spend too much time on it. If you do struggle and you really can't get it, then just look at the solutions and hopefully it should make sense. But let's move on to some past exam questions. Now, fortunately, there's only one past exam question available that just asks you to factorize some expression. And this is because factorization is a tool we can use within other parts of mathematics. So meaning it's commonly used within other calculations, such as solving quadratic equations. Now the exam style questions and all the examples above are the type of thing you'll be asked anyway, so use those as a guidance. But I hope you found this video on factorization useful and realised that factorizing isn't too tricky. You should find that factorizing double brackets is a lot harder than dealing with single brackets. So I would recommend you watch the solving quadratic equations video, which has a lot more focus on factorizing quadratics, as well as examples of different kinds of quadratics you could get. So that video should clear up a lot of confusion as it goes through lots of examples and lots of little tips and tricks on how to answer the questions. But for now, that is the end of the factorization video.